Oh, I get it. I get it. I just get it now. I'm good. I'm excited to take it and probably use it with the Screencast. Okay, great. I know, I see it.
Mr. Galley, I finally skipped my body. Can we have more time, please?
Like 10 more minutes, maybe 5. Yeah, that'd be good. Okay, pick up your colored pens. Let's see how we did. Number 1, find the value of W. I've got students 10, 11, 9, and 14. Student number 10. I'm sorry? Student 11. Student number 9. Student number 14.
9.
So all of you agree that it was 9. All right, number 2, what is the value of X? I've got student 20, 16, 6, and 3. Student number 20. Student number 16. Student number 6. I'm sorry? 5. Student number 3.
Oh.
Okay, so we have a big disagreement. Okay, we'll get back to that one in a moment.
Wow.
No, come on.
Number 3.
Really?
Number 3, I got student numbers 1, 13, 18, and 8. Student number 1.
I didn't get there. I was like,
Student number 13.
About 1.
Student number 18.
About 1.82.
Student number 8.
About 1.
So, we're going to hold off on revealing the answers to numbers 2 and 3. We'll get back to that in a moment. Let's talk about number 1 for a moment. And how did you accomplish number 1? How did you find the value of 9 for W? We'll start with Tristan and then Davis.
We did MN equal to N.
Okay, and how do you know that you can do that?
The right angle sign on the two right angle signs.
Mm-hmm. Well, I'm sorry, you said the square triangle thing. I mean, we gotta iron out this language because you can't just throw around these words like they're meaningless. So you saying that it's a square or a triangle? Like, what are you trying to say?
On the inside of the square, quadrilateral.
Okay. And you felt that that allowed you to say that 7W plus 17 was equal to 9W minus 1? Because of this over here and this over here? Okay. Davis, what did you do?
Pretty much the same thing. Because I realized I took my head so I didn't know the angle. I first realized that it looks kind of squarish. Then I noticed that angle LMN and angle LPN were both 90 degrees. And since they were diagonal, because I thought in my head, is there any other shape that can have 90 degrees with 4 sides in those angles MLP and angles MNP would not be 90 degrees also. I realized it wasn't.
Okay.
So I realized I was a square.
There's no other shape that could happen? Shelby? Angle, side.
Is equal to RTN,
Mm-hmm.
and then RN is less
Okay.
And then M and R and then R and P.
Okay. I don't know if we have enough evidence to say that. We have these arc marks here saying that these angles are congruent, but there's nothing to indicate that these are going to add up so that they're congruent to each other. I understand what you're saying. That was a good idea. I just don't know if we have the evidence. So Davis pointed out something really important. He said that because this is 90 and this is 90, he thought that this would have to be 90 and that would have to be 90, making this a square. But my reply was there another shape where that could be true, but it not be a square? Dalton? Yeah, it could be a rectangle, right? And if this is a rectangle, then we can't say that that is congruent to that because this side would not be congruent to that side. So we have to figure out how do we show that this is actually a square. Anyone figure out really the full evidence to show that it's a square? Zabari and then Brian? The diagonal what?
Diagonals of the horizontal and here. And good. The diagonals, big straight vertical.
Are they?
Yes.
How do you know that they're congruent?
They're okay. So
You're saying the diagonals, so we're looking now.
empty.
Okay, I just want to make sure everyone can see it. So you're looking here and here.
Yes.
Okay.
So you can prove them congruent. Okay, so you can prove them congruent because you have to prove the triangles R, Q, and S and R congruent to each other. And after you prove those congruent, you prove NPS and prove congruent, and then you have
Okay. Can you do all that? Can you prove those things to be true? Not 100% sure if you can. It's a good thought. We're going to have to go a little deeper. Brian?
It's a square because since it's a rectangle, because all four of the large angles, LMN, MNP, PL, and PLN,
Yeah.
they're all 90 degrees, making it a rectangle. And it's also a rhombus because its two diagonals are perpendicular to each other. Because when they form, they create four triangles that are 45, 45, 90. And then
And I agree that that looks like it, but where's the evidence that says that that's true?
it makes
Because it looks like this is a 90, but I'm not sure if it is.
no.
Couldn't it be 91 degrees and then
No, but
still?
like, I'm not saying that's 90 because like.
But you
when
said it's a 45, 45,
well, yeah,
90
because
triangle.
when you make them, it makes it an isosceles triangle, making one angle 45 and the other angle 45.
But I think we have some circular logic, which is what we're trying to kind of get away from, which is you're saying something's an isosceles triangle because it's 45, 45, 90, but it's 45, 45, 90 because it's an isosceles triangle. Yet nowhere in there do we have the evidence to support either of those conclusions. So you guys are onto it, and I'm not trying to make you miserable and make you frustrated. That's not the point. The point is that, look, we already know that W is 9, so clearly you guys, your instincts were spot on, that this is a square. So we can proceed now knowing that that's a square. So you can now find the answer to number 2 and number 3, knowing that this outside shape is a square. But we know it because I told you, not because you know how to prove it. There's a difference there. Okay? So, the answers to numbers 2 and 3. So now I'm going to throw down the gauntlet. I already have a poster up. You can present a solution to the warm-up to me. If you got all 3 parts correct, you get bonus, and the quarter ends next week, so it's a good time for a bonus. You get bonus 5 points to your classwork homework grade. All you have to do is write your name and your answers to the warm-up, and just put it on my desk or hand it to me, and I'll tell you whether you're right or wrong. Okay? And then we will come back and explore this tomorrow. We're going to explore it again tomorrow. Okay? Any comments or questions? Other than, why won't you show us the answer? Yes?
What's this 25Z? It's the length, right? It's not.
Yes, 25Z is the distance from here to here, and 31Z is the distance from here to here. 4x is the distance from R to N. Okay, so all of these expressions are representing distances. So that was a good question. Probably a question that we should have clarified way back at the beginning, but better late than never. Any other comments or questions? Good. So, of course, you've already titled today's lesson, Lesson 8.5, the subtitle, Properties of Trapezoids and Kites. We've spent the majority of the chapter exploring parallelograms because that branch of the quadrilateral tree was so gigantic. Today, we're going to explore the other two branches. So, our objectives for today are to use properties of kites and use properties of trapezoids to solve some problems. We have quite a bit of new vocabulary that's not hard to figure out and not hard to understand. Kite, we have not formally spoken about. Trapezoid, we haven't formally spoken about. Trapezoid has a number of parts that you need to be able to identify: base, leg, base angles, isosceles trapezoid, and a mid-segment of a trapezoid. So, let's first explore the basics. We see from the quadrilateral tree that the trapezoid and kite branches over here are much smaller than the parallelogram branch. And that's why we had to spend so much time, because each of these branches, there was some significant connection to its parent branch, the parallelogram. So there's a reason why trapezoid is a different branch and why kite is a different branch, rather than being all lumped together. And that's one of the keys for us to be able to differentiate between them. Okay? So let's, again, start with the basics. This is not for you to copy. This is stuff that once you see it once, you'll know it forever. A trapezoid has exactly one pair of parallel sides. That's the key difference. A parallelogram has two pairs of parallel sides. Parallel to top and bottom, parallel left and right. All of these have two pairs of parallel sides. That is not true for trapezoids. Trapezoids only have one pair. And that is the distinguishing characteristic between trapezoid and parallelogram. That's why there's two different branches. Any questions about that? Okay. Also, you end up with two legs and two bases. The bases are the sides that are parallel. The legs are the other sides. And then you have what are called base angles, which are the angles that are formed where the base is. So we have a set of base angles on top and a set of base angles on the bottom. This is going to be important for when we explore isosceles trapezoids. Any questions about the basics? Okay, basics of a kite. What separates a kite is that there are no parallel sides. Zero. So we have a parallelogram, two pairs of parallel sides. Trapezoid, one pair of parallel sides. Kite, no parallel sides. We also have, for a kite, exactly two pairs of congruent sides, and they're consecutive. This is the first time we're seeing consecutive congruent sides. So that's a big difference, excuse me. Consecutive sides. That's why you see this indication here and here. We've spent most of the chapter exploring opposite sides are congruent. Now consecutive are congruent. Any questions about that? Good, those are just the basics of those shapes. Now let's go deeper. So, these are on your cheat sheet, but you're going to need to explore, digest, try to understand. The first two theorems, and I can't give you a good reason why in this case they're separate. Actually, I did have a reason why they were separate. Sometimes we put together theorems as a biconditional so that you actually are representing two ideas wrapped into one, and you're going to see that in a moment. Sometimes we keep the ideas separate. So in the first theorem, and again, the name is terrible, so don't bother with the name. But if a trapezoid is an isosceles trapezoid, then each pair of its base angles is going to be congruent. So this is congruent to this over here. So they're consecutive. And this is congruent to this. Any questions about that? That's if the trapezoid is isosceles. Now the converse. If there is a pair of base angles that is congruent, then it's going to be an isosceles trapezoid. And that's actually why they were separated. I apologize because I did just remember. Because in the first theorem, if it's isosceles, we end up with two pairs of congruent base angles. In this theorem, if you just have one pair, then you are allowed to say that it's an isosceles trapezoid. Any questions about that? Okay. Here's a biconditional. Remember, biconditional, if and only if. Biconditional works backwards and forwards. So it's really two theorems wrapped up into one. A trapezoid is isosceles if and only if its diagonals are congruent. What would the other direction be? If the diagonals are congruent, then it's a isosceles trapezoid. Okay? We have other shapes that have congruent diagonals. Rectangle, square, congruent diagonals. But they also have other attributes that separate it from a trapezoid. Any questions about that? And again, we're going to use all these ideas. So, mid-segment. We explored mid-segment of triangles. There is mid-segment of trapezoids. They are very similar. And so that's a good news, bad news thing. The good news, similar, almost exactly the same idea. The bad news is you have to be able to distinguish between the two. So mid-segment, if this is the midpoint of that leg and that's the midpoint of that leg, the mid-segment divides both legs into congruent segments. And the mid-segment will be parallel to both bases. And the distance, the length of the mid-segment, will be half the sum of the bases. And that's what I've expressed right here. In a triangle, the mid-segment is just half the base, but a triangle only has one base. Trapezoid has two. Any questions about that? Okay, I'm going quickly on purpose, so just stick with me. Now, kites. We have two theorems. If it's a kite, then its diagonals are perpendicular. If it's a kite, then exactly one pair of opposite angles will be congruent. If you end up with two pairs of congruent angles, if this somehow ended up being congruent to that, that would actually change the shape. It wouldn't be a kite anymore. We'll talk about that in the future. Any questions? Any concerns? Good. So let's jump in. You do not need to copy the text of the question. You need to read the question, and you're going to do a sketch of the diagram. Okay, so we're ready to explore, and I'm going to give you an opportunity with your team to try and figure out. So I want to clarify a couple things before I turn you loose. A dowel. Hopefully you knew this already, but that's a dowel. It's used a lot in crafts and construction. Clearly I'm using it for something else. This is a dowel. And so kites need to be sturdy enough so that they don't fall apart, but they need to be light enough so that they can actually float and fly. And so a dowel is pretty sturdy. It's made out of wood, but it's very light. So what you do is you cut the dowel using a saw or something sharp, and you use it to form pieces that will construct the kite. And so that's what this fantastic character Lucy did. And then she just needs one more piece. She needs the piece that's going to go straight down the middle. So the question is, if she has 36 centimeters of dowel, how much will she have left after she cuts the piece for that middle? Questions about the setup? Brandon.
Does she have the 36 before the 18 centimeters?
She has already established the 18, the 30, the 27, and the 27. Now she has 36 centimeters left. Now she's got to do the middle, okay? So I'm going to put 2 minutes on the clock for a 2-minute team talk, and I want you to strategize how you're going to approach this, how you're going to find that missing distance based on what you know about these shapes. So go ahead and give it a go. This is not a matter of getting right or wrong, it's a matter of exploring. You see if you can figure out whether or not there's enough evidence to support that.
Yeah, I did that. And I got this. This would be 30, okay? 16, that's 16. Because you split it in half. And I was trying to
Oh, got it.
and you can do it on your side.
Because I thought we were going to J and L was on. Oh,
This? I just got this. Okay. What you do? What? Wait a second. I know.
That's to complete the entire thing.
I know that.
Not this.
Not yet.
Oh, because I thought, I like how you see it laid out.
Okay, so quite a few of you are trying to work through it, and I appreciate that. That's awesome. I want you to pause for a minute, though, just so we can collect our thoughts, and then I'm going to send you back out to try. So I've highlighted, again, just to emphasize what we're looking for. We need to know that distance because we need to know exactly what piece to cut. So what thoughts, what ideas did you come up with for finding that distance? So we'll start with Sebastian, Ania, Davis, and then Anne. Okay, so I like how you said, because it's a kite, we can conclude that that is a right angle because they are perpendicular. Very good. Excellent. I lost my order. Is it Ania? Go ahead.
Well, I thought that A for the bisector would be 1/3 of A.
Okay. Why? Okay. Well, what if what if each one of these was a hinge, and I was able to pull on this in that direction, and pull on this in this direction, and stretch it out? Do you think it would still be 1/3? Okay, so I know where you're getting that idea from, but there's no support necessarily for that conclusion unless you can find it, okay? I lost my order again. It was Davis and then Ann. Go ahead, Davis.
Just from one of the things we learned today, if it's, as Sebastian said, it would mean the diagonals were perpendicular. And since they're perpendicular, you have to, never mind.
Okay, I can never mind. You gather your thoughts. We'll come back to you. Ann? Okay, so we now know that this is perpendicular, and so I think Sebastian said we can use the Pythagorean theorem. But we only have this one distance here, and I guess if I'm looking at it accurately, that would have to be A, and that would be B, and then this is C. How are we going to get the other information that we need? Chris? Oh, okay, go ahead. What did you conclude?
Okay, so there was one theorem, I remembered it, had something to do with right triangles and altitudes. So, I probably should have done this, but I assume that, okay, so, T,
Okay.
perpendicular angles,
Okay.
B and 2, which is each other on the left side.
Okay.
There's one theorem that basically, yeah, those two. There's one theorem that basically said that if you draw a line from the altitude to the hypotenuse of the right triangle, that it would form two similar right triangles.
Yeah, you're absolutely right. So if we're just looking over here, and this is perpendicular right here, but the problem is we don't know if this is a right angle.
Well, I mean, I'm using the theorem backwards to prove.
Okay, so you use it in the converse. Okay, go ahead.
So then, two right angles would show that, like, it's hard to explain.
Okay, that's fair. So gather your thoughts, see if you can work it through. Okay, and there was, okay, we'll come up here, 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 and here. Go.
We can find B because we know that it's 30 centimeters.
What's 30 centimeters?
The length from J to M.
JM is 30 centimeters, as it says in the text, and it's also indicated up here. Okay.
And so we split that in half because the diagonals. Yeah.
Okay.
Diagonals, they got split in half and they equal 15.
Okay, well, so what do you want to say is 15?
A B.
B, you want this to be 15. Okay, so I'll bite on that for a moment. Excuse me. And we'll say that that's 15, but the question is, can you say that that's 15 from here to here? Is there evidence to support that? Is there a theorem that says that the diagonals of a kite bisect each other, or that one of them bisects another? Is there anything that you've learned so far? Jada? It says they're perpendicular, but it doesn't say that they bisect each other. In other words, this whole line, I'm going to draw it in blue. If I take that line and I move it over, is that still perpendicular?
No.
It's still perpendicular, but it's not bisecting JM anymore, is it?
It's gonna be equal because 27 on the bottom.
Okay?
That's why they're equal.
Okay. Well, there is actually plenty of evidence to support Maria's claim that that's 15. For example, because this is 18 and this is 18, what type of triangle is this on the top? That's an isosceles triangle. And so if this is bisecting that angle, because it's a diagonal going straight down, what do we know about an angle bisector of an isosceles triangle? What does it also do? Brandon? It bisects the base as well. So we can conclude that that is 15. So Maria's claim, and I know a lot of you also had the idea that this is 15 is valid. And now we can go back to Sebastian's idea and use these three values. Well, one of them's A, so use the two values to find the missing value of A. That's wonderful, except we need this piece. That only finds us that piece. What are we going to do about this piece down here? Catalina? Okay, use the same thing. What do you mean? Okay. Okay, very good. And so when you say do the same thing, what is it that you want to do? We need the distance from here to here.
Never mind. I was thinking,
Okay, so we can do the Pythagorean theorem again. In this case, 15 would be the A, then B is missing, and then we have C over here. So we basically have to do Pythagorean theorem, add the two results together, and then we were really asked how much wood will she have left after cutting. Dalton and then Michaela. But you made an assumption that that was a 90-degree angle. We don't. What evidence is there that that's a 90-degree angle? KL. So. What if the kite looked like this? I didn't do that very well, but let me get rid of that. What if the kite looked like that and I bisected it straight down, right down the middle there? Would that still be 90 degrees? Okay, so you can't assume that that's 90 degrees. Maybe it is, maybe it isn't, but you can't assume it. Okay? So we have a plan put together from help from everybody. So now let's execute the plan. Find me the distance from K to L and tell me how much would be left over. You already figured it out?
I wanted to answer.
Okay, so well, I've got A. Someone tell me what is A based on my diagram. What does A come out to? Michaela?
I got 3 radical 11.
3 radical 11. Can someone support that or refute it? Shelby, you agree that that's 3 radical 11? Okay. What about B? What does B come out to when you find that one? Maria?
6 radical 14.
6 radical 14. Well, since we're talking about actually cutting something, and I can't really use a tape measure with radicals, can we put this in a form that will actually make it so that we can do this? What is 3 radical 11 equal to, Jada? Approximately 9.49. And what about 6 radical 14? What's that approximately equal to? 22.4. Okay, 22.4. We'll have to go with that for the moment. So, is that right? No?
Oh wait, the first one is 9.9.
Okay, so let's back up. 9.94.
Yeah.
And what's this one?
45.
22.45.
4.
Okay. I'm trusting you guys. You guys got to speak up. You guys got to, come on.
That's correct.
Okay, good. So now we've got the pieces of the distance. Now we need to put it together to get the whole distance. So what's the whole distance from K to L? Alicia? 32.39. And so we've got the whole distance, and now we've got 36 centimeters to cut with, so how much will we have left over? Go ahead, Chris. Okay. So it's what? Okay, but we have exact measurements. So, okay, well, I don't need to waste time on this. I mean, we can just go 36. 36 minus 32.39, 3.61. Okay, so we have 3.61 centimeters left over. Okay? So, comments, questions? Brian, Michaela.
Is there a theorem that exists that states if the quadrilateral is a kite, then the large diagonal bisects the smaller one?
Not that I saw, but it seems a logical conclusion to me. Seems like it's got to be out there, so I'll do a little more research. Michaela and then Chris?
I got 3.6, but I did it with the radicals.
Okay.
But you can just add A and B before you do any of that, and then you can just move the radical that comes out of that into a decimal, and you can just do it like that.
Okay. And it worked?
Yeah.
Okay, good. Chris? Okay. All right, thank you. And Dalton, did your theory that this was a right angle work out to get the right distance? It did. So that was actually a right angle. Interesting. So this KL came out to 32.39 when you did the Pythagorean theorem with those two numbers? Interesting. You're the first person to propose the idea. Good job. Okay. Any comments or questions? Good. So you got 2 questions to answer. Got 3 minutes.
Oh, dear. Oh, my. No, I feel like I did the wrong game.
All right, let's see how we did. Part A, what's the measure of angle BCD? I've got student 3, student 7, and student 4. Student number 3. Okay, student number 7 and student number 4. So 2 out of the 3 of you think that it is 76. What about the measure of ABC? I've got student 13, 1, and 5. Student number 13. Okay, student number 1.
52 degrees.
And student number 5.
Oh.
So we have a massive disagreement. Anyone want to chime in just by volunteering? Brian, you got yours?
Yeah. 115 degrees.
115, so that agrees with Zabari, Sebastian, and Davis.
Same thing.
115.
Comes out to 115.
Question.
Yeah.
Well, if you're doing the angles like that, then how is it a kite? I know.
What's your question?
It said the quadrilateral is a kite in exactly one pair of opposites.
So this is a kite, and it says DAB is 54
I
degrees.
see
So
what I did.
this,
Oh.
you thought it was what?
I looked at the angle.
Okay. Okay, so Brian asked a question, and I quickly looked it up while you were working. There is a theorem that says that this this diagonal bisects the other one. These, and it's kind of contingent on knowing that these are called the vertex angles. I don't know a good way of explaining that. I just looked it up. It's brand new for me. So these are called the vertex angles. These are non-vertex angles. I don't know why they chose that name. That seems a little strange to me. But the diagonal connecting, I guess you would call it the kind of longer diagonal. The longer diagonal will bisect the shorter one always. And it's called the kite diagonal bisector theorem. You don't have to know it right now, but it's logical. We've already used it a bunch of times. Okay? Any comments or questions? Any concerns? Danielle? Which one? Okay. So, DAB is 54 degrees. This whole angle is 54. CDF is 52. So we can put a 52 right there. Did you fill that in on your diagram? Did you fill in this? So now tell me what's that right there? What's that? Okay. So by the triangle sum theorem, you got 90 and 52. You can figure out that angle. And so you can figure out pretty much every single thing from there. Okay? Okay, but you were asked, okay, they are congruent. This angle is congruent to this one. It doesn't mean that this angle is congruent to that one. You assumed that once you had this side, that side was also 52. That's not what it says. It says opposite angles are congruent. So this one is congruent to that one. You assumed that that was bisecting the angle. It's not. Okay? This one is bisecting, this one is not. So these are good questions. It takes some time. All right? We're going to keep going. Don't worry, you will figure out everything. So, let's introduce trapezoids into the mix. KB is 21.9, MF is 32.7, find FB. So, I'm going to do this with you. We have a trapezoid. It doesn't say it, but we can see it because the parallel indicator's here. We also have some tick marks here. And so what can we conclude about the overall shape based on the information in the picture? Jada? Yeah, it's an isosceles trapezoid, which means that we could also put in that that is going to be congruent to that, and that's going to be congruent to that. We can also say something else. What else can we say? Because it's isosceles. You can look. Ania, you see it? What's angle bisecting? Okay. Does it look like they bisect each other? Okay, so you guys gotta look, because we're still learning. I don't expect you to know it off the top of your head. Alicia? The diagonals are congruent. And so FM is congruent to KJ. So we have MF is 32.7. We've got KB is 21.9. So we don't know this piece over here, but we know that it must be equal totally to this whole diagonal. So we know that the missing piece plus 21.9 must equal 32.7. That will give us that missing piece. So that's just either some mental math or quick calculator work. And so what is that missing piece? What is the distance there, Dalton? 10.8. And so since they're congruent to each other, and this point is cutting them into two segments, the segments must be congruent to each other. And so this segment must be congruent to that segment. And so FB must be 10.8. So all we did was build the evidence first, then come to conclusions about what we have, and then use the information to find what's missing. Any concerns or questions about that? I know I went more quickly on that one. Any concerns? Good, because I wanted you to have an opportunity. So, similar idea, similar picture, but I want you to explore and try and figure this one out yourself. Got 2 minutes. If you finish before the time is up, consult with your teammates to see if you've got the same response. All right, let's see how we did. What value of x would make this an isosceles trapezoid? I've got students 8, 12, and 18. Student number 8. Student number 12. Student number 18.
X equals 3.
X equals 3. Any questions or comments on checkpoint number 2? Give me a thumbs up if you got that right. So I had a legitimate reason for going quickly through the second example because I knew that you guys would be okay. So put your thumbs down. So now let's introduce the last idea of the day, which is the trapezoid midsegment theorem. So I've put what you learned already up here as well, just so that you can see how they relate to each other. On the left, you see the triangle midsegment theorem. You learned this quite a while ago. DE is the midsegment of ABC. DE will be half of AC. You can also see that this is congruent to that, and that's congruent to that. So the trapezoid midsegment theorem is the same idea. This is the midsegment, and EF will be half, but instead of it being just half of the base, we have two bases. So we actually add the bases together, and then cut it in half, and we get the midsegment. Any questions about what you're seeing here? Okay, so let's use the idea to find EF. We have a trapezoid, we can see that, and we know that EF is the midsegment, and here's the key part, is that taking the moment to acknowledge those indicators right there tell you that EF is the midsegment. Once you can say that it's a midsegment, now you can use the midsegment theorem, which says that EF is going to be half the sum of the bases. Half of 13.5 and 8. It's basic math. What is it? 10.5? So we get 21.5, so yeah, it's going to be EF equals 10.75. We don't have any units of measurement. You can say units or just leave it blank. And so we get 10.75. Any questions about that? Any questions? Okay. So go ahead and try it out on your own. You got 2 minutes. If you finish before the bell rings, then compare your answers with your teammates.
Maria, have you changed your family member's line? Are you sure you're all
Did I go? No, I'm saying some idiot. I'm lying and I'm calling something else.
Jesus. Write it in rapid.
I wasn't calling you Mexican. Nobody said you were Mexican.
Okay, so let's see how we did. I gave you slightly higher level, not much, slightly, and let's see how we did. I got student 19, 17, and 10. Student number 19, what'd you get? I'm sorry? Student number 17.
Oh, sorry. EH.
Student number 10.
What?
You messed up.
Did I make a mistake?
Yes. You did.
Okay, let's find out. So how'd you do it?
Because
I have no problem saying I made a mistake. How do you do it? Someone tell me so I can see if I made a mistake. Shelby, start us off.
Plus X divided by 2.
25 plus x divided by 2. Like, okay, so let's see, multiply, I can multiply that by 2, so that's 33.
Yes.
33 equals 25 plus x, so x clearly is 8. So clearly that's incorrect. So I apologize for that mistake. Thank you for correcting me.
What led you to get that answer?
So anyone have any comments, questions on this? Zavari and then Jason.
such an easy way to do it.
Go ahead.
You just do 25 minus 16.5, you get 8.5, and then you do 16 minus 8.5,
It's my turn to shine.
It's my turn. It's not more about time. It was my
Wait,
turn.
what? Okay,
Okay.
Jada, go ahead.
So did you like put the answer on purpose? I bet he did.
No.
You're smiling. You're smiling.
Okay, Alicia, Maria, Ania, Davis.
I multiplied 16.5 times 2 and then I subtracted 25.
Which is pretty much what I did. I just wrote it out as an equation. Is that what you were gonna say?
Yeah. Did you say because we know?
Okay, because this is half of the sum, then you know that it's double. Well, I don't know. That makes sense. It logically works. Okay, Davis.
Well, what was your path of logic to get to that answer?
What
The one that was wrong.
the 13?
What was your path of logic?
It was clearly flawed.
Yes, please. I want to see how it was flawed.
I don't know. I don't remember what I did.
Oh, good.
Ania?
Are you done, David?
He's done.
I'm done too.
Go ahead, Ania.
I cut 16.5 in half, and then I cut 25 in half, and then I added it together, and then I times it by 50, and then I cut
I don't know if that's necessarily a method that I want to emulate, but if it works for you and it works every time, go ahead.
Okay, I'm gonna put this.
Okay, so our homework is page 540, numbers 10 to 27, 34, 36, A, B, and C, and then 39 is a 4-point proof. Make sure you spend the time on the proof and make sure you grade it appropriately. Total of 26 points. Online, do the at-home tutor for 8.6. You will have a test on chapter 8. Let me see. Tomorrow and then it will be Tuesday.